Here, welcome to my YouTube channel. So we are continuing our discussion with simple linear regression, and in this video we are going to discuss about how can we find a best fit line or how can we calculate the coefficients using gradient descent algorithm. So before discuss about gradient descent algorithm, we need to know like few terms. Okay, so the one is like error, residual or loss function. Okay, so error is the difference between the actual value of y and the predicted value of y. Okay, consider this graph here or image. Here we can see a green line. Consider this as a best fit line. Okay, so we can see a y hat here, or we can see a point, or we can see a y predicted, okay, on the green line for some x value. Okay, but the actual value is at the top. Okay, so the error means the difference between the actual value minus predicted value is called the error or residual or the loss function. So another term is cost function. The cost function is average loss function over the training data. Okay, so consider if we have 1,000 records are there in our training data set, so we will be calculating error for each data point, okay, or each record. Then we will be calculating the average of it. Okay, so that is called the cost function. So in error, that means only one is single record, but in cost function it's the average of all the training data. Okay, so there are different kind of cost function is there based on their use case. So in the regression we will be there are regression cost functions are available, then binary classification cost functions are available, and multi-class classification cost functions are available, and each this category also like there are a lot of subcategories also there. Okay, so that is we can discuss in maybe in another video. So in this video we are going to discuss about a cost function or regression cost function called MSE. Okay, mean square error. So this is the formula of MSE, that is E is equal to 1 by 2n sigma I is equal to 0 to n yi minus mx of I plus c all square. Okay, so we can discuss each and every variables here. Okay, so this y of I means a single record or the actual y value, that is called the yi. Okay, and this mx of I plus c is the predicted value. Okay, so this is yi is the actual value and mxi plus c is the predicted value. Okay, then so this is the error, right? Yi minus predicted value, that is called error, and we are squaring that error. Okay, so that is this square about. Okay, so this calculation we are taking for each record I is equal to 0 to n. Okay, so we discussed that in a cost function, if we have like 1,000 records are there, we will be calculating error for each record, right? We discussed in our previous slide. So here we are summing up all the errors. Okay, then we are calculating the average of it, that is 1 by n. Okay, and here you may have like two questions. So why we are squaring it and why we are dividing it by 2? So the square means, so consider if you don't have this square, okay, and if the formula is yi minus y predicted, that is mxi plus c only, then what happens is that in some cases we will get the positive values, and some training data we will get the negative value. So there is a huge chance that this will be, after subtracting this term will be completely come to 0. Okay, so in that case we will not be learn anything. Okay, so that is why we are squaring it to avoid the negative values. Okay, so there are two cases are there to avoid the negative. We can also use the absolute values also, so that is also a one possibility, but in this particular tutorial we are using this MSE, okay, the mean square error. So in mean square error we will be calculating the squaring. Okay, so I hope that is clear. And one advantage is that when we square the data, it will be easy to differentiate. But one drawback is it is very prone to what we call the outliers. Okay. For example, if we have an outlier, definitely this yi minus mx by plus c or y actual minus predicted will be a huge value. So when we squaring it, then it will be double, right? So that is a drawback. So we need to carefully, we will be carefully do the all the data management before we select the cost function. Okay. Okay, so then the next question is why we have 2 here, 1 by 2 here. Okay, so this is, we are adding this 2 here to for the mathematical simplicity. Okay, because we need to do some partial differentiating with this function. So I will show you that. Okay, so when we do a partial differentiation of this particular function, we will have a what we call the 2 will be coming as a multiple here. Okay, that will be like 2 into yi minus mx plus c, mxi plus c, right? So we will be easily able to cancel out these two values. I mean these two and the two that we will get after the differentiation. Okay, so I will show you that when we go to the example, I will show you that. So simply understand that we will be using, where we will be dividing it by 2 for the simplicity, mathematical simplicity. Okay. Okay. Now coming to next slide. Okay. So gradient descent algorithm. Okay. So it's a very simple algorithm. Okay, in simple algorithm, what it says, this is the major 4 steps of the of this gradient descent algorithm. One is choose a starting point, or that is called the initialization. Okay, so our goal is we need to find out a best fit line, right? So consider, for example, if you have a y is equal to mx plus c. Okay, so for m and c, we need to initialize some random value. Say we will be start with 0 for m is equal to 0 and c is equal to 0. Then we need to calculate the gradient at this point. Okay, then so I will explain it in detail. You will get, so just understand that we have to calculate the gradient. Then we need to update the m and c values with this gradient. Okay, then we need to repeat these 2 steps. Okay, so it's a, consider it as a loop, it's a for loop. Then when we need to exit from the loop, okay, so that is says the maximum number of iterations reached. So in 2 cases we will exit from this loop. Okay, when the maximum number of iterations are reached, or if there is some threshold is reached. So we will say that, okay, if the cost function is almost like maybe 0.001 or something like that, we can stop the iteration, or we can say that, okay, you will do like 1000 iterations, then stop the exit from the loop. Okay, so these are the 2 scenarios, that is 2 exit conditions for the from the gradient descent algorithm. Okay, so what we can do, we can see how can we calculate the gradient and how can we do the updation of the coefficients. Okay, so we already understood that we have a error function that is called 2 raised to n sigma I is equal to 0 to n. Okay, yi minus mxi plus c all square, right? So this is our cost function. Okay, so what we need to do, so here we have a 2 parameters, that is one is m and other one is c. Okay, so we need to calculate the gradient. What we need to do, we need to do differentiate this error with m. Okay, also we need to differentiate this error with c. Okay, so first what we can do, we can differentiate it with m. Okay, or I can call it as a dm for the simplicity. Okay, so this will be, I can say that dou by dou m, this entire function. Okay, so that is, I can say that 1 by 2n sigma I is equal to 0 to n yi minus mxi plus c all square. This is c and this is all square. Okay. Now I am going to differentiate this. So this 1 by 2n, I can simply make it outside. So this is 1 by 2n. Okay. Now I am going to differentiate this with m. Okay. So here consider if we have a x square, okay, then how we will do that? How we will differentiate that? This is equal to 2x. Okay, then we need to differentiate x, that will be 1. Okay, so this answer will be 2x. Similar to that, what we need to do, so consider this entire record as x. Okay, then this will be x square. So when we differentiate this one, this will be 2x, right? So this will be into sigma I is equal to 0 to n. So this will be 2 into the x will be yi minus mxi plus c. Okay, now we need to differentiate this function. Okay, so here when we differentiate by dou y of I divided by dou m. Okay, so since there is no m is available, this term will be 0. Okay, so into this will be 0, then minus now this mxi. So when I differentiate this mxi, okay, then this will be xi plus here c. So there is not term m here, so this will be also 0. So finally this will be 1 by 2n. Okay, I can take this 2 outside, then sigma I is equal to 0 to n. Here yi minus, so this I am going to call it as a y hat I. This term, this is the predicted for the simplicity. Then here I have a minus x of I. Okay, so this minus I am going to take it outside. So this will be minus 2 divided by 2n sigma I is equal to 0 to n x of I minus y hat predicted. Okay. So this is called dm or dou e by dou error. Okay. Similar to that, what we need to do, we need to calculate the DC. Okay, that is dou e by dou c. Okay, so when we calculate the dou e by dou c in a similar way, you can do the calculation. So I am writing only the final result here. So this will be minus 2 by n. Okay, sigma I is equal to 0 to n yi minus y hat predictor. Okay, so this is called the dm. Sorry, this is called the dc. Okay, we have the dm here and this is our dc. Okay, so this is one formula and this is another formula. Okay, so this is another formula. Now what we need to do, we need to update this m and c. Okay, so what is updation formula? That is m is equal to m minus l into dm. Okay, for c this will be c minus l into dc. Okay, so this l is called the learning rate. This L is called the learning rate. Okay, so the learning rate will help us to learn in a faster way or slow down it in a okay, I will say in a different way. So the learn will help us to control the movement of this variable. Okay, these points m and the c. Okay, for example, consider a parabola here. Okay, So this is our point. Okay, this is our point. So if the learning rate is small, okay, so this entire term will be small, right? So this is actually a minus, right? So what happened is that the jump will be very slowly, we are jumping from here to here. Okay, then we will reach the global minima, okay, or minimum point. So if n is very large here, so what will happen is that m may be, the jumping will be like very high. Okay, so from the last time it is from here to here, right? Maybe sometimes it will go to from here to here, then here to here, then here to here, then here to here, then sometimes it will come back here, and this way the jumping will be very high. Okay, so the L is a what we call a trainable parameter. So we need to figure out, or we need to do a trial and error with different learning rate to get the optimum value. Okay. Okay, so so let me say it again. So as we said, first what we need, algorithm says, okay, first we need to initialize m is equal to 0 and c is equal to 0. Okay, then we need to calculate the y. Okay, then we need to calculate the gradient. Okay, so that is we need to calculate the dm. Okay, and we need to calculate the dc. Okay, then next step is we need to update the variables. We need to update the m and c. Okay, then we need to update it, then we need to repeat the same process. We need to update this process again and again until it is reaches the some epoch level. Okay, until it reaches the epoch, or it reaches the some threshold value. Okay, I believe this is clear. If you have any questions, please put it in the comment box. I will try to answer that. And only thing is I didn't explain is how to calculate the DC. Okay, so I have explained how to calculate the DM, and in the similar way you can calculate the DC. Okay, so if you have any questions, please put in the comment box. I will try to answer that. Okay, now we can go to our slide. Okay, so we explained about this. Now we can see how can we calculate it with respect to the Python programming language. Okay, so here I have already done it. Okay, so I will explain this code. Okay, so here we have two values, one is x and the one is y. Okay, and x has like 0 1 2 3 4. Okay, and y is a value like 1 3 2 5 4. Okay, so let me execute this. Okay, so here we can see that the 2 points are here. We have done a scatter plot, and what we are doing here. Okay, so as I mentioned, we will be doing m is equal to 0 and c is equal to 0. Here we have set the learning rate as 0.001, and I have, let me first set the epoch as 1000. Okay, now I am taking the number of points here, n. Okay, so see this loop. So we are continuing like 1000 times. We are calculating y predict with m and the c. Okay, so initially m is equal to 0 and c is equal to 0, right? Then we will be calculating the dm, and we will be calculating the dc. Okay, then this is also explained. Okay, then here we are calculating the m. Okay, m is equal to minus l into dm, and we are calculating the c, right? C is equal to c minus l into dc. Okay, so we will have new c and new m. Okay, so again we will calculate the predict, and we will do the same process. Okay, so here we are using the number of epochs as 1000. Now let me execute this. Okay, so we got m as a 8 and c as a 3. Maybe you guys can play around with this. I will share this video. Let me put it like 9000 epochs. So here I got 1 and c as a 8.1. Maybe I can change it to 0.1. Then I can see what will happen. Okay, then we are getting some other values. So the goal is you guys can try with the different parameters and you can try it out. So, and we need to find out the optimum values of L and the optimum values of I mean the number of epochs. Okay, so that is all about in this video. Okay, so if you have any questions, please put in the comment box, and please don't forget to like and subscribe. Have a nice day. Bye bye.